There's no place like production. There's no place like production. There's no place like production. Getting your boot apps to Josh Long's favorite place on the internet is made safer with certain techniques. Our next talk, Spring Boot Production Boost, will teach you all about them. Please welcome Thomas Vitale.
Hi, everyone. Welcome. I hope you're having a great day here at Spring One. I'm Thomas Vitale. I work as a software engineer in Systematic, a Danish software company. I'm really passionate about Spring Boot. In particular, I really like working with cloud native technologies. I'm even writing a book about it. It's called Cloud Native Spring in Action, where I talk about how to build modern applications like microservices using Spring Boot and deploying them in production with Kubernetes. Today, I'd like to go through 5 main areas in order to boost your journey to production. It's very important to move fast and be in the market with a product that our users can really love and use. I'm going to go through 5 areas: JVM and containers, data integration, configuration, testing, monitoring, and management. And we'll do that in a very practical way. We're going to build a small application that can be used by to manage books in a catalog. It's called Book Service. It will expose a REST API to users, and it will store data in a PostgreSQL database. So let's get started. Our first stop is at start.spring.io. From the Spring Initializer application, we can start a new project. In particular, I want to start a new Gradle project using Java, the latest Spring Boot version. The application will be called Book Service. And I want to use Java 16. Now, to expose a REST API, I will use Spring Web. I'm going to build an imperative application and use Tomcat as the embedded server. Then I need the driver for PostgreSQL. This is the database that I'm going to use. Next, I have 2 options provided by Spring Data in order to implement the data layer of my application. I can use Spring Data JPA, which is a very popular choice based on the JPA specification and Hibernate. And another option is Spring Data JDBC. It's a newer option. I really like it because it's based on the principles of domain-driven design, and I think it's an excellent choice for microservices. So that's what I'm going to use today. Next, since we want to go in production, we need to take good care of our databases because our data are really important. So what I want to use as well is Flyway. Flyway will let us version control our database, but we'll see in a minute its power. Then we need to think about how we can test the application. It's extremely important that we write auto tests before going in production, and we can leverage the Testcontainers library. Finally, cloud native applications need to be observable. So we need to get visibility into its internal state when they run in production. So for that goal, I'm going to add Spring Boot Actuator. That's it. These are all the dependencies that we're going to use. So I'll move to the IDE and we'll start implementing the book service application. Here we have a standard Spring Boot application, and I want to start by implementing the domain model. I can do that with records. So I'll define a record for books with 2 fields, an ID field of type long and a title field of type string. The ID will also be the primary key in the database, so I'll use the ID annotation to mark it. Next, I'll define a book repository interface, which extends the CRUD repository interface provided by Spring Data. It's a repository to fetch books which have a primary key of type long. And here I want to pause a second because I'm really amazed by this. Like, we can implement the data layer of an application with just 2 lines, combining the power of Spring Data, which will automatically implement this interface for me, providing all the methods to run a CRUD operation, so to create, read, update, and delete books. And also I can use records because Spring Data JDBC encourage using immutable objects. So with 2 lines, we have our data layer implemented. I really like that. Then we need to expose the REST API to manage books. So I will create a REST controller. This controller will handle requests to the /books endpoint. Let's call it book controller, like that. So first of all, I need to inject book repository because that's how I access the database. And I'll use constructor injection, which is the recommended way of doing this. Then I'll create a method to return all the books in the catalog. So I'll return an iterable of book objects, get all books, and I'll return this dot book repository dot find all. This is one of the methods which are provided by Spring Data through the CRUD repository interface. Then I want a method to add new books to the catalog. So I'll use the post mapping annotation, returns a book. So add new book. And the book is specified in the request body, like that. And then I'll use another method, once again provided by the Spring Data CRUD repository, which is save. And this is all I need to do to implement my logic. We have the data layer with the domain model and the repository, and we have a controller to expose a REST API. The next step is making sure that when we start the application, in the database, there's actually a table to store book data. And for that, we're going to use Flyway. Now, if you think about your application source code, it's now a given that we use version control, so track all the changes in a Git repository where each change is represented by a commit. Now, in a similar way, we can use Flyway, and each change applied to the database is registered as a migration. That's how Flyway names it. So in the resources folder, I can create an SQL script. This will be the first change that I apply to the database. So I'll call it V1. This is a naming convention from Flyway. And we'll use it to initialize the schema. We can write migrations both in standard SQL, like I'm doing now, or in Java. So create table book. This new table will have two columns, an ID column of type big serial, which is also the primary key. And then we have a column with the title of the book. These two types, big serial and varchar, will be mapped to long and string in Java. Using Flyway is really convenient, and I think it's important to use a tool like Flyway for production, because then we can really keep track of all the changes that we apply to a database, and we can reproduce the state. So this is the first version of our database, but maybe in the next release of book service, I want to add a new column to the book, for example, to store the author of the book. And at that point, I can create a new migration script. It will be version 2 in order to create this new column. So when the application starts up, Flyway will check all the migration scripts. And if any of them has not been run yet, it will run it. So it will ensure that the state of the database is always consistent and it's always healthy. The final thing we need to do is configuring Spring Boot to interact with a specific PostgreSQL instance that in this case I have running on my computer. So I'll open the property file and I'll configure the URL. I'm using JDBC, it's a PostgreSQL database. The instance is running on my local host on port 5432. And the database is called Book Catalog. Then I also need to define the username and the password, very secure, like that. And that's it. This completes the implementation of our application. Most of the work has been done through the Spring Boot auto configuration and through the power of Spring Data. This is really important because the time to market is a strategic advantage for organizations. So we really want to go to production fast. That's where our application brings value to customers, users, and to the business. We don't know if the application works, so we need to write some auto test because we want to have high quality code. And we have a few different choices. Of course, we could write some unit tests they wouldn't be different than with any other Java application using JUnit and Mockito. In that case, there's no Spring involved. And we could also write integration test. Integration test, and you get an example when you initialize a project from start.spring.io, can be configured through the Spring Boot test annotation. By using this annotation, I can set up a full Spring context, including a web environment, exposing its services through a random port. Random because I don't care where it's running, because my focus will be on testing the application. And I can do that in different ways. One of the options is using the web test client utility, which is a client that I can use to call the book service application and test, for example, that I can add a book to the catalog correctly. So what I'll do here is, first of all, creating a book. The ID will be handled by the framework and the database, so I'll just pass null. And then the title, for example, The Hobbit. Then I can use web test client and send a post request to the URI/books. This is what we defined in the REST controller. Then I want to pass the book to create in the request body. And then I'll send the request. At this point, I expect to get back a successful response. So I can use expect status is 200 successful. And also I expect to get back the book that has just been created. So it should be of type book.class. And I also want to check what is inside. So I'll define the actual book here. And first of all, I want to assert that now the book created in the database has an ID. So the ID should not be null. And then I want to assert that the book title is the same as the one that I previously specified. So it should be equal to book to create dot title, like that. So now I could run this test, but it wouldn't work. And the reason why is that the application running in the test context would try to call the PostgreSQL database through this URL. But we need to do something because this PostgreSQL database is running on my computer. So how can I make sure that the test is self-contained? I can use Testcontainers, which is a great tool built on top of JUnit that provides containers for all your external dependencies. So you can write integration tests using the actual external dependency. And that guarantees the environment parity, because then if in production we're using Postgres, it's important that we use Postgres also for our auto test because it makes them reliable. If we used something else like the H2 embedded database, it would still work, but it wouldn't be 100% reliable because it's a different database compared to what we use in production. So what we need to do is overriding this value and pointing to an instance of PostgreSQL provided by Testcontainers. So I can do that in a few different ways. A very convenient one is using the test property source annotation. And from here, I will override the property Spring data source URL. And the new value will be JDBC. Then TC, which stands for Testcontainers. This is a convention used by Testcontainers. The database should be PostgreSQL version 13. And I'm missing a column. Yes. Then under the hood, when I run the test now, Testcontainers will initialize a new PostgreSQL container specifically for the test, and Spring Boot will run the test against that instance. When the test is over, then the container will be shut down. So let's see now the result of the test. And it's green. This is great. We can run this test now everywhere as long as we have a container runtime, and we can be sure that it's reliable because it's using the same database that we're using in production. Now, I'd like to point out something. This application is an imperative application. If you're working with reactive Spring, you need to be aware that Flyway, which is also run as part of the test, doesn't support the R2DBC driver for reactive applications. So what you have to do in that case, besides defining the data source for your Postgres, you also need to configure Flyway explicitly because it will use a different driver. But everything else will work the same, both for imperative and reactive applications. Perfect. So we are almost close to be ready to deploy the application in production. We need to think about what will happen once it's up and running there. We need to have a way to get visibility into how the application is doing, how it's behaving. And that's why we added the Spring Boot actuator to the dependencies list of the project. Spring Boot actuator exposes different endpoints with different information. Now, for this presentation, I will expose them all, but I recommend you only expose the ones that you actually need. There are different endpoints. A very useful one is the health endpoint, which provides information about the health of the application. By default, it just returns an up or down status, but you can configure it and show more details. So we can add information about the components used by the application, more details. And if you're running on Kubernetes, you can also enable the probes. Now, they are actually enabled by default if the application is running in Kubernetes. Since I'm running it on my local computer, I need to enable them explicitly. Having said that, let's run the application. We can first ensure that it works fine, of course, the business logic that we implemented for the book catalog, and then we check the Spring Boot actuator endpoints. The application is running, perfect. So what I do now, first, I want to create a new book. The port is 8080/books, and the book will be The Lord of the Rings. And it's created correctly. Just to double check, we can also send a GET request to the same endpoint. And this endpoint returns the full catalog of books. Of course, we have only one, so that's the one that we are getting. Then all the Spring Boot actuator endpoints are prefixed with /actuator. So for example, I can get information about the health with /actuator/health. For example, you can see that the database is up. So the integration of Spring Boot with Postgres is okay. And you have also information about the liveness and readiness states. These two states are really important for Kubernetes, and you can get them through specific endpoints. So the liveness state, if it returns a down status, then Kubernetes will restart the container because it means that entered a faulty state. Instead, if the application is not ready, it means that it cannot handle more requests. So Kubernetes will stop sending traffic to that specific instance. Other useful endpoints for our case, the book service application, are Flyway actuator/Flyway. From here, we can see all the information regarding the migrations that we ran. This information is stored in the database. I can show you, I switch to the database view. You can see that Flyway will create automatically a Flyway schema history table. And in here, it will store the status of all the migrations that have been run. There's also a few more endpoints that I'd like to show you. One is the Prometheus endpoints, which returns useful metrics about the application. So you can scrape them from a Prometheus server and show them in dashboards, for example, using Grafana. And if you are dealing with memory leaks, which are really annoying bugs that we might have in our code, it might be useful getting a heap dump. So a snapshot of the heap memory from your application so that you can investigate further where is the memory leak and fix performance issues. At this point, we really have everything we need to go to production. So we need to prepare the application to be deployable. We have two main options. One is packaging the application as a jar, and this jar is a fat jar, is standalone. So it includes all the dependencies needed by the application to run correctly. There's no external dependency except for the Java virtual machine. So I can run it with java-jar, and I can take it and deploy to platforms like Cloud Foundry, like Heroku, or to make the application even more portable and deployable on platform like Kubernetes, as easily I can package the application as a container image. And there's a task both for Gradle and for Maven. The Spring Boot plugin under the hood uses Cloud Native Buildpacks, which is a specification to convert application source code into container images without the need to provide a Docker file. It's really great. In particular, Spring Boot is using the Paketo Buildpacks implementation, which produce production-ready images, which follow all the best practices in terms of security and are optimized both for building and running. And my favorite feature is a component called Java Memory Calculator, which is included in the final image, and that it will configure the Java virtual machine running in your container at startup time. So you don't have to do that explicitly, configuring the heap and all the non-heap memory areas. And that's great, and it helps us in our journey to go to production fast. And here it is, we got a container image back. This is ready to go in production in any containerized platform. I'd like to point out a few things that are useful when you do that. So I'll go back to my slides now. First of all, it's about how to configure the application, because we used property files for our local development environment, but there are different strategies you can adopt. In the Spring ecosystem, you really have many different options that fit any need you might have. A strategy that I'd like to share with you today is the following. I would use property files to define default values and values that in general you would use in your development environment, like we did earlier with the URL for the local Postgres instance. Then for all configuration data which are not related to the infrastructure, you might use a configuration service like Spring Cloud Config. So things like connection pools, timeouts, feature flags. And it can be any configuration service, either run by you or managed by a platform, or even provided by the platform as a service. For example, if you're running applications on Azure, you could use Azure Key Vault and integrate it with Spring Boot through the Spring Cloud Azure project. Finally, if you're running on Kubernetes, I would use config maps and secrets, which, by the way, are supported natively by Spring Boot. You don't need anything else to make that work. I would use them for Kubernetes-specific properties. So, for example, service names of other services running in Kubernetes, or which profiles to activate in a Spring Boot application. Talking instead about configuring the container itself, so not the application, it's important to take care of how we assign CPU and memory to each container. Notice that the CPU is a compressible resource. So when the limit is hit, the process is throttled. The application would still run, but maybe with lower performance. Instead, memory is a non-compressible resource. If we hit the limit, then the application dies with a dreadful out-of-memory killed error. We don't want to do that. So pay attention to how you configure both requests and limits for both memory and CPU. In particular, memory, it's important to set both the request, which are the minimum value assigned to the container, and the limits. And for JVM containers, we usually assign them equal, because that guarantees the best performance with the JVM. And the CPU, if you want to get some performance boost, especially at startup, you could omit the limit, since we know that it's a compressible resource, so the application will still run. It would just be throttled. The final thing, remember to use the liveness and readiness probes that we had just configured in Spring Boot Actuator. So you can use them, and Kubernetes will manage the container in a nice way. This was our little journey to production. We went through these 5 different areas. I really thank you for joining this presentation. I hope you liked it, and I wish you a great rest of the conference. I also want to thank the organizers that make this possible. Thank you very much.
Thomas, that was great. Really appreciate it. Josh, you made Josh Long proud in helping many, many people get applications more securely into production. So really appreciate it.
I'm glad to hear that. Thank you.
After this, be sure to click on the join the conversation link to join Slack, where you can find the Q&A link. When you do go to Slack, make sure you also check out our sponsor channels and show them some love. They help keep the videos coming and make all of this possible. Our next talk will be at how to improve stability in your integration test capabilities so you can stop ignoring those broken builds. We'll start the next talk at 1:05 Eastern.